Welcome to the second part of real-time clock project. In this part we have had, as you see, a second peak microcontroller which is producing a sound, a melody coming through out of this buzzer as an alarm for our clock. The melody is the happy birthday song, and then we have normally the LCD, the RTC and the 4 buttons, which not anymore being polled by the code, but it is work with interrupt on change in this part. Let's see how the things goes. The first button is the setting time, date and time and date. The second button sets the alarms, both of them, and then we have a plus and minus. So we set the first alarm, we leave it there at 10 o'clock, and the second, zero one, set it and go back in the main screen waiting for the alarms to buzz. The alarm is on, the first one. The alarm is off, and now we wait for the second one. And this is the second alarm. With the same way, we stop it, pressing the plus button. Now let's go and see we bit the changes on the code has been made. This is the code of the slave, produces the sound. We use a PIC 16F, the 18346. As you see here, there is a definitions of the nodes. These are the original names of the nodes, and beside you see the frequency in several octal. Here is all the functions we use, is the timer and the PWM. In the beginning we have a sound, just to be sure that the peak and the buzzer is working here, and then the incoming variable keeps the incoming data from SPI, from the master. When this is 1, the LED is on for a visual of the alarm start. Then we start the timer for producing the PWM, and this is the playing of the melody. We also polling the buffer status. When the buffer status became 1, it seems that we have received a message to close the alarm. So the LED is getting off, the timer stops, and we go out of that while loop. This is the slave. On the master, as we see here, we use the same PIC 16F 1829. The changes we have made here is the buttons. They are not polling anymore. The codes has also add the SPI functions. So we see here the initialize. Then we have write a byte. This is read a byte. This is data ready, and we have write a string, read a string. On the main, as you can see, down in the while loop, you see anymore there is no polling. is just an interrupt on a change. So when the output of each button goes from high to low, pressing it we change in low. So this is causing an interrupt and stops the normal flow of the program and gets into the edit clock or edit alarm. All the other things has been remained the same. And the other change we have already also made is if we go here on the read-write alarm and scroll down to the edit alarm, as you can see here in that point here, that's that point here, we have an effect of blinking. So when we make the change on the time up or down, we see the number on the screen and then we wait 200 microseconds and then we show a space and then goes back again showing the number and space and number and space, and with this way changing between space and the value we make the effect of blinking. This is the same doing everywhere. This is the changes we have done. I hope it's very simple and very easy for everyone to understand at least the basics, and from there on, after a while and getting more experience, can make better code, better execution code for that project. On the description, under the description in the video, I'm having all the details and the file, which includes the code complete, ready to go, and also includes the Gerber files and bills of materials if someone wants to do the board and stick all the parts on there and have it and realize the project. Thank you very much for watching. I hope help a lot, and until next time, keep safe and see you again.